Good afternoon, everyone, and welcome to a virtual tour of outer space. My name is Josh. I have the special honor, nay privilege, of being your presenter today to get a chance to fly you, our audience, through space. Normally, we do programs like this in our own Morrison Planetarium, and we're looking forward to the day when we get to re-welcome audiences back to that space. But for now, we decided a fun substitute would be us coming to you in your home environment, from our home environment, using a planetarium we are familiar with, our planetarium software, I should say, we are familiar with in our own dome. That's one called OpenSpace. OpenSpace is an amazing program for a number of reasons. Number one, it lets you fly through the universe as a whole and see some really amazing stuff. That's awesome. But to me, the coolest thing about it is that you get to do basically the same program if you download it to your home computer. So it's a free download. Check it out. Let us know what you think. We're going to do a program now in OpenSpace. You can see it floating there on the side. And we would love for you to let us know what you think of OpenSpace. There should be a link we'll share at the very end for you to follow. And that'll give you the chance to give us some feedback, which we find incredibly valuable, as do our friends at AMNH, the American Museum of Natural History, and NASA, who are creating this project and sharing it with the world. So if the first 30 people who follow that link and let us know, we are going to send you a NASA meatball sticker. So please let us know your feelings. I should, before we fly away, we are starting very close to home in our very own neighborhood, not too far from us at the moment. This is our own moon. Now, from here in San Francisco, for the past few nights, my wife and I have been going outside right after the sun sets and seeing a beautiful crescent moon, which is a great way to kick off that autumnal spirit. So we are entering into our harvesting months. We just passed our equinox, and that tells us that we are getting closer and closer to the shorter and shorter nights of our year. Now, let's see, from planet Earth, if we can guess where Earth would be based on the fact that we are seeing a crescent moon. Now, we're looking towards the Earth-facing side of the moon. Turns out one side of the moon faces Earth all the time. The other side faces away. I can cheat and prove it to myself by going right around here and turning off nighttime on the moon. That lets us see the entirety of the moon's face. So I'm going to try something of a trick shot here in the planetarium world. I'm going to try and fly us backwards so we bonk into planet Earth. Okay, you with me? If you're bored of me flying around the moon, please suggest another place for us to go visit. I love suggestions from the audience. In fact, it's kind of the focus of this show. So we're bringing back nighttime. I'm going to see if I can dial us in to the same crescent moon we saw yesterday. I'm going to say right about here. And now I'm going to fly backwards, and we're going to see how close we get to planet Earth. Let's see how close I am. If I hit it, I get 10 extra. I missed. Okay. So we should have been right around here for us to be lined up perfectly between planet Earth and the moon. But if we lined ourselves up just right, so we fly through the planet, you can see that cute little crescent right there. That's what the moon looked like last night. That is a picture-perfect representation. I'm going to say I got pretty close. Ooh, Justine's got a great request. Let's go check out Saturn. Thank you, Justine. I love that suggestion. Okay, so Saturn is going to be a big trek from home. We have sent human beings to the moon. We have sent human beings nowhere else in our solar system. That's the only spot we've sent them. Now, someday soon, we are planning on sending human beings back to the moon, maybe to Mars, and there are ideas about sending human beings even farther, not necessarily to land on Saturn, but maybe to land on one of Saturn's moons. Sounds like Sharada has the same idea. Titan is actually a place human beings might one day go. And if you want to find out more about those explorations, tune in again, either on our OpenSpace YouTube channel, the SETI Facebook channel, or our own Facebook channel, to watch us talk to Pascal Lee. He's an amazing scientist who is focused on where human beings might be headed in the next few generations. Now, landing on Saturn itself would be a daunting idea. That's because there isn't really a place to land. You can see that beautiful shadow cast from this planet makes it seem like a solid ball, but that's really not the case. We call this a gas giant, and that's because the outer layers of this world are just gas. If I zoom in as close as I can get, you can see that what looked like a uniform color at first really isn't. It's got these delicate patterns and swirls going across the surface. Saturn is a beautiful planet even without the rings because of these delicate features. Now, you don't see a great red spot. You don't see fancy cloud bands, but you do see some unusual stuff. We get weird vortices that show up from time to time. If you look at this in thermal imaging, like the Cassini spacecraft was capable of doing, you get to see some tremendous variation in the temperature of the clouds. And if we head all the way up here, you can see one of Saturn's most mysterious features hanging out on its pole. Same as we did to the moon, I'm going to pretend there is no nighttime on Saturn. And when I do that, check this thing out. It's a little tough to see because we're doing a light feature on a light background, but I'm going to go carefully with my mouse. You look, there's a straight line here, 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 and a straight line here. And that makes 6 straight lines. So this makes kind of a delicate hexagon floating around the pole of Saturn. We're not exactly sure why Saturn has a polar hexagon, but it does. Now, that's a weird feature, and one we are unlikely to better understand until we do a lot more computer modeling and a lot more understanding of Saturn. Its most awesome feature, of course, you got those flat rings. We got a request from Reginaldo for Enceladus. Let's go check that out. I'm also going to swing by Titan, too, because I think today Titan might be my favorite moon. Okay, Enceladus. Zooming on out. Now, sometimes when we zoom up on Enceladus, all we get to see is a smooth gray ball, completely featureless. I'm going to give it a second just to see if my computer can maybe catch up. But some days, it's just not happy. Okay, well, Enceladus looks like a smooth white ball from a distance, not gray. When you get close, you can see some very interesting, very delicate cracks along the surface, and you get to see some really cool stuff. Another request for moons, let's go see Callisto. Maybe we won't get the same moon problem. I don't have Callisto loaded. I'm so sorry. You folks are making excellent moon requests, and I cannot fulfill them. How about Titan? Ooh, Jupiter's storm. We could do that. Okay. Amarenda suggested Jupiter's storm, and my sassy question to you, Amarenda, would be, which storm? Jupiter's got a whole bunch of storms, but I'm being silly. I know exactly which one you're talking about. Check this out. When you look down on Jupiter, you can see storm, 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 storm everywhere. You thought that the Atlantic has a lot of storms right now. Jupiter's got way more at any given moment, and they're huge. See this little white one right there? I can say with a high degree of confidence that's about the size of planet Earth. For a good scale, the one I kind of return to time after time, is the thickness of this band is about 1 Earth tall. So I would say this storm is about an Earth-sized storm. Now, you might think a storm the size of our planet is the super exciting one that we were looking for, but Amarenda, I'm willing to bet, was thinking of the Great Red Spot. Now, you can almost just see it right there. Can you pick it out? Looks like a scary monster eyeball hanging out on the side of Jupiter. Let's turn off nighttime on Jupiter, just like we did before. Give ourselves a chance to see that Great Red Spot. Now, that is a huge storm. You could fit about one. Let's check. So around here, about that big would be a planet Earth. So I'm going to say at least an Earth and a half, maybe almost 2 Earths across the Great Red Spot. But the thing about the Great Red Spot is, we've talked about this a little bit in past weeks, it's changing. It's getting smaller from our perspective, but there is some evidence to suggest that it's not actually shrinking, it's getting taller. It could be extending down farther into and farther above the surface of Jupiter. So the real answer is this thing is changing in a way we don't fully understand. That's cool. It's a little unsettling, but ultimately it teaches us that while we know a bit about the outer surfaces of gas giants and ice giants like Uranus and Neptune, there's a lot we don't know about their insides. Now, I wanted to stop right before we take off and check out Sam's idea to go see Europa. Look at this goofy face on there. That's one of my favorite things in the solar system. There was recently a photo popped up on the internet of 2 little dots. I can't tell if they're actually dots on the surface of Jupiter, maybe like eyes of the storm, or else moon shadows, but they line up perfectly with 2 spots, and it makes it look like Jupiter has googly eyes, which is just about the best thing I've ever seen. Okay, Sam suggested Europa. Let's not keep Sam waiting. I'm pretty sure Europa loads, so let's go there now. So from this distance, it's hard to tell. Is that a featureless gray ball or Europa? Let's find out. This looks like Europa. Now, again, kind of smooth. That's the icy surface, but smooth only in kind of macrocosm. When you get down to micro, it gets very lumpy. Very lumpy. I don't see a single smooth part on here. When you see a weird straight smooth part like that, that's actually our limitations of our imagery. Europa doesn't have big smooth landing strips on it like that. What we're seeing is kind of a hole between these two images of very high resolution surface detail. That's kind of a cool spot. Check that out. You see that very dark patch right there? I've never noticed that before. Now, it could be a tall feature and we're seeing a shadow. In fact, I'm pretty sure that's what we're looking at there. But it also kind of looks like those skylights we saw on Mars. And actually, we might be talking about more next week. If you tune into our last week's Cosmic Conversation, we learned about those skylights and how they might prove to be a fertile environment in a place like Mars. I wonder if Europa has any skylights or places that you could look inside. That would be really cool, especially because we are pretty sure that inside Europa we are going to find a treasure trove of water, resources for us to examine, and maybe one day find life. Now, human beings love exploiting resources. When we find resources, we use them. That's an awesome, super cool thing to do. But, when we're looking for water resources, we have to be careful out there in our solar system because getting those water resources might mean that we are out competing anyone who could already be there. We got more requests for Callisto. Given the popularity of Callisto this week, I promise you I will try and figure out a way to get it loaded up for next week. But alas, I do not think I can fulfill that this week. But Mercury, that sounds like a great proposition. Let's go check out Mercury. Okay, so zooming to another part of our solar system, now we are going very far in. Now, as we get closer and closer to Mercury, check this out. While the OpenSpace sun, it's a very colorful sun in this view. You can see some reds and yellows there. This is actually about how big the sun would appear from Mercury. It's pretty large in the sky. Think about how small the moon looked when we looked at it from Earth. This is a big sun compared to what we have. It makes sense. Mercury's closer to the sun, so the sun would appear larger. But when we're talking about the distance from Mercury to the sun, imagine, if you will, if there were 7 planets between Mercury and the sun. Between the Mercury and sun. That's not the correct way to say that sentence. So between Mercury and the sun, if you had 7 little planets lined up there, that would be a pretty densely packed area, right? Well, turns out we found a solar system like that. The TRAPPIST-1 system actually has many planets in a short distance from their star. Granted, the star is a lot smaller than our star too. It's a teeny tiny star, but still, it's a very short distance for a planet to be from its star. Okay, so looking at Mercury, I got distracted thinking about other solar systems. You can see a surface that might remind you of the moon with one major change. When we look at the moon's surface, you might have noticed some flat black plains called the mare, the oceans of the moon. That's what people are usually looking at when they imagine a figure like the man in the moon, the person in the moon, the rabbit in the moon, the T-Rex riding a tricycle on the moon. There's a lot of things you could imagine there, but they're looking at those dark spots generally. When you look at Mercury, it's harder to imagine a person on the surface of Mercury because there aren't many dark spots. Now, some folks have imagined a snowman on Mercury, but that's much less of a defined regions and much more of 3 craters where you've got a big, medium, and small right next to each other. And given how many craters I can see on Mercury, it's not a terribly challenging thing. We could find a pretty poor snowman if we just look for a couple minutes. I see one down here that looks like binoculars. But yeah, crater gazing is fun. If you ever want to do something and spend some time, download OpenSpace, fly around, and see what interesting craters you can spot. When I think of a crater, by and large, I think about a round thing, but that's not always the case. Ooh, we got a question from Sharada about the poles of Jupiter. Do we have hexagonal storms just like Saturn? I'm inclined to say no. But there's a really cool way to test that hypothesis. Let's give this a shot. So we saw hexagonal storms on the surface of Saturn. We are now flying to Jupiter and see if we can spot an analogous feature. Something maybe not identical, but similar. What do you think? Now, I can actually tell you we're going to have a little bit of a problem. This is where our image was stitched together. So it looks like there's a perfectly round spot on the surface of Jupiter. That's not actually the case. We do see some similar kinds of banding as you get closer and closer to the surface, but you really don't get that perfect hexagonal storm. In fact, I would say that the one on Saturn is unique in our solar system We don't even have a matching storm on Saturn's southern pole. It's only on the northern pole, if I recall correctly. Ooh, rings of Uranus. Actually, Sam, you're really good at this today. We don't have rings on Uranus in OpenSpace. It's a feature we've been asking for a while, and maybe one day it will get added, but it would be really cool to have the rings of Uranus in OpenSpace for one extra special reason. Check this out. When we fly to Uranus, the first thing you might notice is the unusual color. Get that nice bluish sheen. Little bits of yellow mixed in. Very interesting looking, to be sure. Got some dark clouds, got that light yellow polar region. But when you look at this planet, it doesn't seem that unusual, right? Just a planet. Looking towards the sun, you can see, well, okay, it's a planet. Their sun's off in the distance there, lighting up this side of the planet. What's so interesting about Uranus? Well, think about where the North Pole was, that yellowy region, okay? And think about where the sun is touching right now, right about there. That's a pretty big shift. Now, in order to really tell where the North Pole is, let's see if we can't bring up our orbit lines. And I'm going to do that. So the North Pole is actually around here. You can see the sun's over there. But the actual pole is there. What's going on here? Well, it turns out this is a planet that is knocked over on its side. So the rest of the planets kind of spin, pirouette like ballerinas through the solar system. This one's laying on the ground and rolling side over side as it goes through the solar system. And that's a fact that is instantly obvious if you have rings on the planet, because the rings wouldn't be going around this way from side to side. They'd be going around this way. So if we can add those one day, I think that would be a great way to illustrate one of the coolest features of Uranus, aside from the silly name, aside from the cool color. Haumea. Bing is my producer. He's killing me today. You're asking for all these amazing solar system objects, and I just can't go find them. But when we get far enough back, we can see about how far Haumea travels from the sun. It's in the outer regions of the Kuiper belt. That is really far. Now, when I say far, you can never trust an astronomer when they say far. Everybody means something different. Galactic astronomers mean something different from planetary astronomers. Planetary astronomers mean something different from like solar system archaeology astronomers. And then you get to the worst of all are the cosmologists. And when they say far, oh boy, they mean far. But right now, I can say that we are pretty far from the solar system. I would hazard the guess that we are now about maybe 12 light hours away from the sun. It might be a little closer. So 12 to 15, let's say. Now that's pretty close. This might be about where Haumea spends a lot of its time. But when we're talking about the outer reaches of the Kuiper belt, they go a lot farther. And then you can go all the way out to the Oort cloud. And to tell how far we are, I'm actually going to go in here to our dashboard and click on a little thing that gives us distance. So right now we are less than 1 light month away, and I'm betting that's a unit many of you have not heard of before. That's how far light would travel in 28 and a half days, I think. But now we are getting out to a couple light months away, nearing up on half a light year. We have to go still farther to get to the outer edge of the Oort cloud. In fact, we've got to go beyond 1 light year to 2 light years. That would be about where the outer edge resides. When we get to 2 light years, you'll notice the unit changed again. It's going to be in parsecs. Now, parsecs, what is that? Well, George Lucas used it maybe as a measure of time. I'm a big fan of Star Wars, but I'm also here to tell you that is absolutely not a unit of time. A parsec is a parallax of 1 arc second, which means that between June and December, you should see that star wiggle a 60th of a 60th of 1 degree. That is a teeny tiny measurement. But if there was a star this distance away, 1 parsec, we would see it wiggle by just that much over the course of 6 months. Okay, now way out here, you can see there are no stars within that distance. that's kind of the disappointing thing. No star gives us a nice 1 arc-second movement, but there are some that are just a little bit past 1 arc-second. You can see some of our nearest stellar neighbors there. We've got our buddies out. The actual closest star is going to be, I would guess that one is going to be Alpha Centauri. And there's actually a slightly closer one, Proxima, that is a teeny tiny red object. It doesn't give off much light. We can't really see it with our eyes, but surveys have shown us that there is a slightly closer star to us than actual Alpha Centauri. Okay, now getting back to our neighborhood, our neck of the woods, we had a request I saw earlier for a black hole. We don't have a black hole in our solar system. We don't have a black hole nearby in space that we know of. We do have a supermassive black hole that's nearby. Again, when you talk to a cosmologist, they would say it's nearby because it's in the middle of our galaxy, right down there. That's Sagittarius A star. That is a super cool black hole if you want to look it up. It's actually a supermassive black hole, which is a lot more than just a cool song from the band Muse. We had a request earlier to see some features here on planet Earth. I'm going to embarrass myself if I try and do too much flying blind around the surface of our planet, especially looking for national parks. But I can take us down to the surface of Earth where we get to see some pretty awesome stuff. Check this out. Death Valley. That's usually a pretty good one to spot because it's big and empty of light. That's where astronomers like looking, is where you've got these dark spots on our planet. You can actually see in the nighttime maps where there's a lot of lights from human cities. There's a lot of human cities that don't make as much light, to be sure, but for a lot of heavily developed areas, you can see them glowing brightly in the nighttime sky. Now over here, you can see the east coast, I should say, of South America, east coast of the U.S. We can wave to our friends in New York who are tuned in. And over here to the west coast of the U.S., right up there. Okay, now I gotta say, wonderful news. Our smoke layers are dying down significantly in big stretches of the west coast. We still have fires down south and fires up north, but we have amazing firefighters doing their absolute best to knock them back. And for many of us here in the Central Valley and on the west coast, the air quality has gotten a lot better. So between the weather and their efforts, things are much better for us here. You can see a lot of interesting things around our planet, including these bright, shiny lines. It actually tells us a really cool thing. It tells us when these photos were taken. Now, that shininess is actually sunlight bouncing straight back up at the spacecraft that took this image. That's the Suomi spacecraft. NASA and NOAA partner together. They study together space, air, and the ocean, and they take these amazing photos of our planet once a day. So these were shots taken right at noon. You can see the bouncing light of the sun directly going back to the satellite overhead. Now around here, we get our own beautiful planet Earth. So let's see if I can spot a region at least close to Death Valley. Again, if I mess this up, please don't yell at me. I'm working hard. I'm a product of California public schools, so my geography ain't great, but I have a feeling Death Valley is somewhere around here. Southern edge of the state, this may be a little triangle-y area. That looks like a valley. In fact, we can do something super cool to find out topography, the elevation of stuff, which is, again, just using OpenSpace. So let's drop on down. This is Mexico. I recognize some of those cities. But down here, we've got a little bit of farms in a pretty beautiful area, actually. It's always cool to see farmlands from above. Now, sometime soon, I should show you one of, I think, the most interesting spots you can see here on planet Earth. That could be a virtual tour of outer space, right? Just looking at Earth? Maybe not. You have to go outside of Earth for an outer space tour. But there are really cool places to see here on our planet. Around the Salt Lakes of Utah, you can see some really cool stuff. North of Las Vegas is evidence of the American nuclear weapons program. And you can see some huge craters on planet Earth caused not by objects hitting us, but by us blowing ourselves up. Really cool and awesome to check out. Sharada's got another idea. Let's see some aurora. I'm looking. I know we have aurora built in this software. I don't think I have them loaded up on my profile. But you can see little aurora around the surface of our planet. What we're actually seeing is our magnetic field from planet Earth directing particles from our sun that slam into our planet's atmosphere and cause it to glow. So you can see different colors reflecting different elemental compositions of what they're striking. So I flew too far south. you can get kind of our North Pole region, and then down here, past Australia, our South Polar region. And you should see some kind of auroral display around either of them during those intense solar storms. So let's see. I'm looking to comments. Ooh, the sun from Sam. I think that sounds like a great idea. Okay, let's go check out the sun. We saw it from Mercury, but there's really no replacement for going up and seeing it up close and personal. Now, one other cool thing about OpenSpace software is you get to look at the sun without burning your eyeballs. Looking at the sun with your just naked eye, staring straight at the sun, can hurt your eyes. Absolutely. There are some people who wonder what it would be to look at the sun through a telescope. And let me tell you, that is an experiment best left undone. You can really damage your eyes even with a brief glance at the sun through a telescope. In fact, it's so hot, so much energy, you can even damage the telescope. This is a great snapshot of the sun's surface. You can see all sorts of cool things going on, but this is a moment when the sun was very active, at least a layer of the sun where you can see a large amount of activity. The layer of the sun we are used to seeing is called the photosphere. Now, the photosphere is where sunspots might be visible, but our sun right now is very boring to look at. So I can understand why people would use a more exciting image, because showing you a flat yellow ball wouldn't be that exciting. But that's what our sun kind of currently looks like. If you want to find out about solar weather, what's going on, all the cool things happening there, there's a great site. The SDO Sun Today gives you a cool perspective on what our sun is doing at the moment. And every so often, when you're getting bad cell phone reception or your TV signal's not coming in just right, and it's a persistent thing throughout the day, or maybe starts within a couple hour time period and won't go away, go online and look up what's called the K index. If you look up the K index, you can see what the solar weather was like here on planet Earth. We have monitoring stations all over the globe. And if you think about it, the K index going up high is probably really good evidence that some people here on planet Earth are going to get a chance to see aurora. So for Sharada and Chloe, if you want to go when there's a high K index, grab your tickets and head to one of our poles, and you might get a chance to see those aurora for yourself. I think we have time for at least one more object. Let's go see Venus. Real quick, last 3 minutes. I hate to cram Venus in because there has been so much Venus in the news of this week and last week. We have discovered phosphenes floating in the atmosphere of Venus. That has a lot of F and V sounds and is a fun sentence to say. When we talk about these particles in the atmosphere of Venus, those are particles that can be created by life here on planet Earth. So finding them in the atmosphere of Venus is very exciting. However, smart money is that we're probably going to discover that there's a process within Venus that creates these particles, that it's not aliens burping them out. Now, we would love to find aliens in our solar system. Venus has never been a top contender for where we would go looking, at least not for a long, long time. Once upon a time, scientists suspected there could be something like jungles hanging out underneath the clouds of Venus because we couldn't see there, and we had reason to suspect that it might be a warm place. It's closer to the sun than us. Once we began understanding the surface temperature of Venus, we immediately discovered it would not be a place life would survive as we know it, because it was around 900 degrees Fahrenheit. However, in the upper parts of Venus's atmosphere, it's what our expert last week described, Dr. Bywaters, as t-shirt weather. It's not that hot. It's not really a place you could breathe, but if you evolved on Venus and you hung out in that environment your entire existence and your evolutionary existence, why not? The atmosphere of Venus could be a perfectly lovely place for life to survive. So there is a little bit of murmuring from people who come up with space missions about the possibility of us sending something out there sometime soon. I think that would be a great place to check out. But I think every place in our solar system would be a great place to check out. There are so many cool things to see. I've got to thank all of you for all the wonderful suggestions today. There have been a huge flurry of activity in our comments, which is always a cool thing to see. I will try and get some of those assets loaded up for next week. If you want to tune back in, I will do my best to take us to Callisto, or at least some more objects in our solar system that you folks have requested today. But help us out too. If you can give us some feedback on the OpenSpace software, we would really appreciate it. Follow that link from the comment on Facebook or on YouTube. Just click on it and you can take the survey. And again, the first 30 people to take it get that super cool NASA meatball sticker. So thank you all for tuning in. From us at the Morrison Planetarium to you, we are very excited to someday soon have a chance to reopen and welcome you back into our facility. We're not exactly sure when that's going to be, but we're hoping sometime soon. So with that, thank you all for tuning in. From myself, from OpenSpace, from the whole Morrison Planetarium and the California Academy of Sciences, we'd like to thank all of you for tuning in, for your wonderful suggestions, and we hope to see you again soon virtually, and maybe a little bit after that in person. Thanks again. Have a great rest of your day.